How many of you know what is this HTML5 thing? How many of you work with HTML5? Very nice. So what I'm going to do is, okay, what I'm not going to do is I'm not going to teach you HTML5 because there are a couple of experts and there is a lot of documentation on HTML5 on the internet available. There are books available. Doesn't make sense for me to waste 1 more hour. In fact, what I'm going to do is, I am very much interested, very much influenced, very much infected with HTML5, and I'm going to spread my enthusiasm across in next 1 hour. And I'm going to do in such a way that when you go back, you will feel the desperate need of looking out in these books and sites and learning something new about HTML5 before going to the bed, believe me. And unfortunately, from the response from the demo in the morning, I have to say this, that feel free to clap when you want to clap and feel free to clap even when you don't want to clap. Okay, so, and as I said, I'm not going to teach anything. Instead, what I'm going to show you is 10 amazing demos. Each one more complex than the previous one. And then I'm going to explain you how to build these demos from scratch. During this process, we will learn a couple of new APIs, new things about HTML5, but that's going to serve as pointers, you know. That is just, remember, yes, I learned something else, something like this. Go back, look in the internet, learn more about it. So believe me, next 1 hour is going to be full of fun, full of entertainment, and full of magic. So here is that magical language. You want to clap? Okay. Again, I'm telling you, when I showed this slide in Hyderabad, one participant told me, your presentation and all that was good, but probably you don't know what is the full form of HTML. It is not here is that magical language, it is hypertext markup language. So I just wanted to, I know it, it's kind of, I wanted to say that this demo is going to be full, this presentation is going to be full of magic. So here is that magical language that I want to talk about, HTML. HTML? Something is missing? 5. And that HTML5, that 5 thing is really important because HTML5 really takes the web development to the next level. The only theory slide in this entire presentation, we will immediately move to the demos. So how does it take web development to the next level? It makes the web faster, more secure, more responsive, and more interactive. It's not just secure, responsive and interactive, but it adds a lot of eye candy. You'll be able to build stunningly beautiful web applications using HTML5. And not just user interface, but there are even APIs that will talk right to the hardware, which make it possible to build applications as complex as desktop applications. HTML5 tries a lot to bridge the gap between online and offline, 2D and 3D, server and client. It helps to development a lot by adding very useful JavaScript APIs, and it makes browsers more secure than ever. Okay, these were some of the bullet points that you will find in every HTML5 first chapter textbook. So what I'm going to show is what you will not find anywhere. So let's move to the first magic moment. The star rating that you will see in front of every magic moment doesn't indicate how awesome or cool the magic moment is. Every magic moment is awesome, and I'm going to ask you for every magic moment to clap. What the star rating indicates is how easy or difficult it is to build. So 1 star means it's like probably 2 or 3 lines of code, and 5 star means probably some 500 lines of code. So let's start with the first magic moment. And as you can see, there is a very nice rainbow spiral that is displayed on the screen. And if this doesn't excite you, look at the controls that are there on the right bottom. Let me just try moving around and see what happens. Okay, so all this has been built by using simply 2 lines of JavaScript and CSS3 code. CSS3 is a component that comes along. So HTML5 is effectively HTML5 plus CSS3 plus JavaScript. And what I'm showing over here is a simple 2 lines of CSS3 code, which will be able to, using which you'll be able to build such a nice rainbow effect. I'll show you what exactly I mean by 2 lines of code. First control is going to tell you the number of figures. So let me reduce the number of figures to probably the least 2. And the second control is telling you the angle of rotation. So let me change it to the least, the smallest possible. So what you see is it's nothing but a couple of squares that are nested inside each other. And this gradient thing that you see across each square, earlier before HTML5 we used to require images for gradients. Now you can just have one CSS3 property that will add gradient to your square. So there are the 2 lines of CSS code as I promised. 1 line adds gradient Second line adds rotation. So on the next screen, as you can see, it's a 2-line code. What I am adding is a background image called linear gradient. Couple of parameters. So you start at 0 pixel with left, red and orange 16% and all that. And on the second line, I am saying transform, which is again a new CSS3 construct. Transform this object by doing a rotation along z-axis. Rotate indicates rotate along z-axis. Rotate by 20 degrees. So what the code goes over there underline is it takes the parameter as number of figures that you want to render, and it takes the parameter as what angle should each figure be rotated with respect to the previous figure, and it just runs a loop and renders the image that you saw on the previous screen. Let's move ahead to the next magic moment. As you see, we have moved from 1 star to 2 star. This is where HTML5 allows you to capture or the webcam stream, and I'll just show you what it tries to do. So it's saying that localhost wants to use your camera. Let me allow. And as you can see me on the camera on the screen over there, and this does not use any plugins at all. This is built into HTML5. The ability to control the camera and the microphone is like 1-line code just because of HTML5. And this demo is not about just this camera. On the right hand side, you can see that there are a couple of controls. I can change the grayscale of the image. I can change, for example, sepia, saturation I can change. I can invert it to look like a complete photo film and all that. I can do a blurring. And of course, I can take a snapshot, and whatever was the change I made, it gets recorded as a photo. So there are a couple of multiple things going on over here. One is the ability to capture the camera, the stream from the camera. Second is ability to apply multiple filters over a running image. And third, ability to take the image and store it in an IMG tag. Let's see how we do this using HTML5. So there are 3 different tags, as you can see on the screen. There is a video tag, which is used to record the video that is going on, my video when I am standing over there. Then there is a canvas tag, which will be used to capture the image when I say take photo. And there will be IMG tag, which is used to render that image. The way you tap into the microphone and webcam is by saying navigator.getUserMedia. WebKit implements it as navigator.webKitUserMedia. So this is something vendor specific. Mozilla will implement it as with a Moz suffix prefix, and Opera will implement it as OP's prefix. So HTML5 standard is currently being developed. There are a couple of things that are still being added, and therefore various vendors will apply their own specific prefixes to show that this API doesn't exactly comply with the API specification specified by the HTML standard. This will go away once the HTML standard stabilizes. So we say navigator.getUserMedia and window.url. We capture these 2 values, and then we say getUserMedia of, I just want a video, I don't want an audio, so I just said video is equal to true, and pass a success function and a failure function. And the success function is going to create an object out of the media stream. The parameter to the success function is the media stream from the camera. It's going to create an object, and we're going to put that object in the video tag. So video.src is equal to, once I put that object, then this src gets updated every time because an autoplay has been added to the video tag, the first line on the screen. Therefore, every moment when I make a movement or when anything in front of camera changes, this re-rendering happens. So that's all about how you capture the video. How you do apply the filters is, again, there is a new CSS3 property called filter. Chrome implements it as WebKit filter, gets added over there. So you can see a couple of properties and values or attributes are associated with WebKit filter. I can change the grayscale, I can change sepia, hue rotate and all that. This is a simple example. Whatever are the values over here, once I just statically apply them, this is how your image will look like. So what I am doing is I am applying those filters over here, over there, and at runtime I am again generating the source of the image and adding it to the video. This is how I was able to apply the filters to that video. And of course, the third point is to take the photo. I'll be talking about Canvas in more details later on. As of now, Canvas is a way by it gives us an area on which I can paint whatever I want. So I'm painting the image from the video onto the canvas and then capturing it to the IMG tag. That's what a couple of lines of code shown on the screen do. One last comment, there is something called document.querySelector and document.querySelectorAll. These are some new APIs added in the JavaScript with HTML5 or with ECMAScript 5. What they do is you can pass any CSS selector. So if there is a class called foo, then you can say document.querySelectorAll.foo, because dot is used to indicate a class, and then it will give you, it's not exactly an array, but something like an array, something like an HTML collection, which will list all the divs that match the given selector. Let's move to the third magic moment. Here is a cube, and I can rotate it using a couple of keys. Okay, again I'll show you how to build this cube using, say 5-6 lines of code. And something interesting is that each face of this cube is a proper HTML tag, a div which has whatever complex code going on inside. So there is a video running on one of the faces, as you can see over here. And if I say hover on this video, and if I then rotate, then even the controls of the video you can see are being rotated along with it. So it's not something that is hard coded, it is an actual, anything that is a valid HTML snippet can go on any of these faces. The way we do that is kind of simple. Point to their proper direction. They're still standing in the center. So when a face gets rotated like this, it's not going to move anywhere. It's just going to, at the center, going to rotate. So that is done by the CSS3 construct called transform, which WebKit implements as WebKit transform. So that's what I'm doing. One, I'm rotating through y 0 degrees, which effectively means I'm not rotating. Other -90, third 90, and so on. Whichever is the correct direction and correct angle of rotation, I'm doing the appropriate rotation. So as you can see here, phase 1 doesn't rotate. Phase 2 rotates through 90 degrees. Phase 3, 180 degrees. Phase 5 through x-axis and all that. If all these effects are added together, this is what we'll end up in doing. So all these faces are rotated along the center, and now they are facing to their appropriate directions. So you cannot see the faces that are facing upwards, downwards, or left and right. You can only see one, and you can see phase 3, which has been rotated through 180 degrees. The next important task is to move these faces to by the appropriate distance so that it looks like a cube. Now this is where a little bit of understanding of three-dimensional geometry comes in the picture. What it might appear is that if a face is rotated like this, I'll move through x direction and it will move like this. If a face is rotated like this, I'll move through y direction and it will move like this. Unfortunately, it doesn't happen like that because transformations are slightly trickier. They are not commutative. What I mean over here is, if you translate an object by say 100 pixels, and then if you rotate by 30 pixels, then this result is not same as if you rotate an object by 30 pixels and then translate an object by 100 pixels. Okay, here is a small demo that will show us that these two things are totally different. So here is a red div which gets translated and then rotated, and here is a div which gets rotated and then translated. It's just translate followed by rotate for the green one and rotate followed by translate for the red one. The reason why they are different is that when a div or an entity rotates, the entire coordinate system also rotates along with it. So when I say rotate this object by 30 degrees, the original x-axis was pointing over here, but the new x-axis starts pointing over here. And therefore, when I say rotate 30 and then translate 100 pixels along x-axis, is going to translate like this, 100 pixel along x-axis. So what is happening is that a face was originally like this. It has been rotated through the center like this. Actually want to say move to x-axis, but what is happening? This was original z-axis. It has been rotated by 90 degrees, so that now the new z-axis points over here, and therefore I have to say translate through z. Similarly, when an original face was like this and was rotated like this is again a new z-axis, so I have to say translate z. If you analyze each of the faces, you'll understand that effectively the translation for each of the faces happens only along z-axis, and therefore after the rotation, if I want to move these faces at their proper place, I have to say translate z followed by whatever distance I want to translate. So here is a simple example what happens. If this seems a little bit complicated, we can do one face at a time. So now one face translation is going to happen at a time. Pay close attention. Phase 2 is moving. phase 4 is moving to the right, phase 5 is moving to the top, phase 6 is moving to the bottom, and phase 3 will move all the way to the back. So this is each of these phases individually, is translated one after the other. This still doesn't look like a cube, and the reason is that all the faces are exactly along the line of sight. These two faces I cannot see because they are along the line of sight. These two faces I cannot see. The only face that I can see is the front face and the back face. The way we fix this is by perspective. Just to give you a quick idea of what perspective is, it is how image appears to a human eye. So for example, if you are standing in front of the railway route, which you know it is parallel, but it looks like the two lines are meeting somewhere at the end. That is what a perspective means. As another example, this clicker appears of the same size as the person standing there outside, not because they are of the same size, but because of the perspective, because of the way the person, the clicker, and the person who is seeing are all placed. So let's use perspective over here, and that is done by, if you can see the top of the screen, there is something called WebKit perspective that will be used to add the perspective. So if I add a perspective called say 1200, and then let's see what happens. So I'm now going to use perspective, and then let's see what happens. See, as each face is moving, you can see the one of the face coming slightly in front is because of the perspective. Okay, still it doesn't look like a cube because only two of the bottom and the right face I can see. I cannot see the other two faces. And the only way I can see is probably move myself to a separate place where I can also see that face and this face. So that is done by changing the perspective origin. So I have fixed the z distance. Now in order to view this cube properly, I have to move somewhere along the x and y axis so that my perspective becomes slightly better. That's where this WebKit perspective origin line comes up. I'm moving 300 pixels across x-axis and 200 pixels across y-axis, and that is, suppose, let's add that, and then this is what the effect looks like. See, now phase 1 is coming in the front because of this. 4 goes back, 5 goes on the top, 6 goes on the bottom, and finally 3 gets completely rotated. Okay, this is how the cube gets formed using this probably 6 to 8 lines of code. This is still a static cube. What I showed you was a rotating cube, and that is achieved by adding a couple of lines of JavaScript code for the rotation. So this rotation has to be applied on the outer div so that all 6 faces rotate in a sync. So it's just a switch case. I have captured keys number 1 to 6, and I'm saying that whichever is the key, if it's key number 1, rotate through y minus 90, or rotate through y plus 90, z minus 90, plus 90, and so on. And the last line of this the second last line of this slide, it tells how to add CSS properties using JavaScript. So I can say div.style.webkit transform. Instead of saying in CSS class webkit transform is rotate something something, I can say div.style.webkit transform is rotate through x like this, rotate through y like this, and rotate through z like this. So these are a couple of probably 25 lines of code that help us in giving that rotating cube kind of experience. Let's move to yet another demo. I think there is some. Okay, let's move to yet another demo. And this demo again shows a very nice addition to HTML5 that as I told, you can talk to the hardware. So this shows how you can talk to the accelerometer of this laptop. I'm lifting the laptop and moving it, and the image moves accordingly. This is made possible by talking to the accelerometer, finding out what is the orientation, and just applying that orientation using transforms on this image. So what you see over here are 5 different images. This looks like a Chrome logo, but it is not Chrome logo. There is a separate red image, there is a separate green image, there is a separate yellow image, and there is a separate blue image, and there is a separate gray image. These 5 images are imposed over one another and have been given a class called layer. And then let's see on the next slide. What I'm saying is add an event listener to an event called device orientation. This event gives me, whenever the orientation of the device changes, this event gets fired, and it tells the direction, the front to back tilt and the left to right tilt of the accelerometer through event.alpha, event.beta and event.gamma. So I get an event, I get all those things, alpha, beta, gamma, I get all those images into the layers variable and just iterate over it, do a little bit of mathematics, and at the end, as you can see, I'm simply applying a little bit of transform, rotate y through a couple of angle and rotate y through some angle, rotate x through some angle and all that. So this is how the rotating effect or the tilting effect can be achieved on this Chrome logo. Okay, now this photo wheel seems to be rotating, and there are a lot of non-obvious things that are going on over here. One obvious thing is that the way it is rotating, this is made possible using something called as animation, which is again supported in HTML5. So there is, so HTML5 not just supports transforms and transitions, but it also supports animations, and this demo is basically a photo frame which is rotating using HTML5 animation. So that is one thing. Second is rotation. You saw that the cube was rotating along its own axis. Here these photos are rotating along a different axis. So rotation along around a specified axis is also something additional that is provided by HTML5. So there is an animation, there is a rotation along a specified axis. There is something else. You can see that there are a couple of images over here. I can drag these images and they just take place of the original images. Okay, and this does not use any JavaScript library for drag and drop. Again, drag and drop is supported natively in HTML5 without any library requirement. So that is what third thing that is demonstrated in this demo. I did a couple of drag and drops. Let's see what happens when I do a back. Look at the picture carefully. Okay, so it remembers what were my previous states of the wheel and it reverts back to them instead of going back to my previous site which was in the browser. This is made possible by tapping into the history API of the browser and telling that this should be the previous state of the browser, this should be the previous state of the state before that, and so on. So the fourth thing that I want to demonstrate in this demo is how to tap into the history of the browser. And there is a fifth thing, probably pretty risky, but let me still do it. What I'm going to do is I'm going to plug off the network cable and I'm going to put myself completely offline. Okay, and the wheel stops rotating, and when I plug it in back, it again starts rotating. So it somehow understands that I am online or offline. The ability to understand whether the browser is online or whether the browser is offline is again one more thing that is provided by, say, one line of API code in HTML5. So there are 5 different things that I want to demonstrate in this demo. There is one rotation, animation, rotation along an orbit axis, drag and drop, capturing the history API, and checking whether you are online or offline. Let's quickly go through each of them. The first line of the code, keyframes or WebKit keyframes for WebKit based browsers. You don't need to take snaps. The presentation is available online. I'll give you the link. Okay, so the keyframes is the keyword that allows you to define an animation. So I am defining an animation over here. The animation is called rotate. It starts from a given state, it reaches to a given state. You can specify, say, at 20% what should happen, at 40% what should happen, and so on. Just for simplicity, I am saying that start from rotate to y0 and move to -360, that is one complete rotation anti-clockwise. This is the animation, and then the way you apply it to the diff picture is by saying that WebKit animation rotate. So rotate is the animation that I want to apply. 6 seconds is the total time that it should rotate for. Linear, the way it should rotate, you can have ease in, ease out, linear. You can specify a Bezier curve if you want to have complex function which should be used for animation. 0 second, that is a delay. So you can say that as soon as this page loads, you start rotating, or you can say start rotating after such and such delay. Infinite, how many times you want to rotate, whether you want to rotate for n number of times and stop or do infinite rotation. And normal, which means that once you go from to to, jump back to from and again go to to. Another value over here that can be added is alternate, in which case the animation will go from to from to to, like that. So these are a couple of options that you use to specify how an animation should behave. And transform origin is how you specify around which axis it should transform. So when I say transform origin as 0, 0, Funnily, it doesn't take 0, 0 with respect to the center of the image, it takes 0, 0 with respect to the top left corner of the image. So this image is actually having a few pixels as padding, and then there is a transparent background. That's how you can see that transparent joining thing, small joining part that you see from the axis. Actual image is initial little bit transparent part followed by the actual image of the line. So rotation along 0, 0 means take the top left corner and rotate along that axis. So the WebKit transform origin 0, 0 is going to specify which axis you have to rotate around. There is another property called rotate 3D, which you can use to specify any r-bit position vector. So if you say rotate 3D 2, 1, 5, 30 degrees, it will mean that go to the position vector 2 I bar plus 3 z bar plus 4 k bar and all that, and rotate along that axis. So take that point, join it to the origin, and around that vector rotate by the given angle. So that is how rotation is achieved. The drag and drop, let me show you what is happening over here. So this is a simple drag and drop demo. What is the way it is supported in HTML5 is anything that you want to drag, you say draggable is equal to true, and what happens on drag start, you specify a function that this function should be invoked on drag start. The reason why you should specify the function is that typically elements are not draggable. Therefore, in this function you should say event.preventDefault, which means that whatever is the default behavior being non-draggable, suppress it, prevent it so that element becomes draggable. Once the element is draggable, whichever is the drop location, you can say on drop over. So whenever on drag start and on drop over. So you can say that if the drag happens on that specific div, maybe there is a plus icon coming over there. So you want to change style of that div, and when the drop happens, you want to, in this case, I'm using the source of the image and putting it in the destination. So whichever functionality you want to execute once the drop completes. So just say on drag over and on drag start and put draggable is equal to true, and like 2 lines of code you will be able to do drag and drop using HTML5. The history API lets us tap into the browser history, and that is done by saying history.pushState. History is again the object given by HTML5, so most of the browsers will support it. You just say history.pushState, and whenever I was dragging a picture, I was changing the URL and adding the picture ID or something in the URL, and that's what I'm pushing over here. So I'm saying that each URL uniquely identifies the set of pictures that were rotating on that wheel. So you push that information in the history so that next time when I do a back button pop state, which will be fired, which will show the images as shown in this second part of the code. So I'm saying that when the pop state event gets fired, which will be fired when I press the back button of the browser, I'll just take the URL, split the URL, get the list of images, and add the images to that photo wheel. So this is how this is how the drag and drop and the history API is made to work. And the network detection is again done by saying navigator.online. Navigator.online returns true if the browser is online. Navigator.online returns false if the browser is not online. Unfortunately, this is not an event. This is only a property, and therefore, as you can see, there is a set interval. Every 250 milliseconds the code is running. It's checking whether you're online or offline. If you're online, I'm continuing the animation state as running. Otherwise, I'm saying the animation state must be paused. This is how when I remove off the wire, it stopped moving. When I put back the wire, it started running. Okay, this is a small demonstration of Canvas. Using Canvas, you can build a lot of complicated demos, but I thought that I wanted to teach from the start how a demo has to be built. So I took this simple demo. It doesn't use any Flash. It is purely, again, HTML5 based, and it's a simple game you can play to break the tiles. Okay. Okay, I can continue on. So what happens is this, as I said, this game has been built purely using HTML5, and the credit goes to this canvas tag that has been added in HTML5. A canvas gives you an area where you can paint whatever you want using pixels. On the other hand, there is something called scalable vector graphics, which is also included in HTML5, which is used for vector drawings. So if you want to do vector drawings, you use SVG. If you want to use bitmap drawing, you use canvas. So I start by saying that I want to create a canvas. what you write between the canvas and slash canvas tag doesn't matter. It is never shown to anybody. Whatever is to be drawn on the canvas has always to be done programmatically. So I initialize the canvas to get the context. This is like every C program starts with stdio.h, something like that, that whenever you start working on a canvas, you have to first get the context, saying context is equal to canvas.get 2D context. If you want to go for a 3D rendering, you should say WebGL experimental, because WebGL is a technology that is used for rendering 3D. It's completely in the experimental stage right now. So I initialize the canvas like this, and this is how I can draw a circle and a rectangle, because these were the building blocks of our demo, our game. Circle can be drawn by using context.arc, which is an HTML, which is a canvas API. So there are a couple of canvas APIs, or you can say canvas functionality that is made available. ctx.arc and ctx.rect are the ones that are used to draw an arc and draw a rectangle. So this is how I draw and fill rectangles. As you can see, there is a fill style provided in the code. Using this, you will be able to fill the whatever diagram you draw with a specified color. Once that is done, second most important thing is to understand how to add this movement, and that is done by repeatedly clearing the canvas and drawing the ball and incrementing its dx and dy by specific value every time. So there is a simple function that is being called every say 10 milliseconds. As you can see, there is a set interval at the end of the slide, set interval draw. Every 10 milliseconds I am drawing this, and every time a draw gets called, I am incrementing or decrementing dx and dy, which will be used to specify the new position of the ball, and this bouncing off is what changes the dx. So if I am bouncing like this from the x-axis, I am going to say instead of dy, do a minus dy, and if I am bouncing from the right or left, I am going to say instead of dx, do a minus dx. This is how the reflection effect is also maintained. So if I come like this, the ball is going to go like this, but if the ball comes like this, it's going to go like this, because dx and dy are changed appropriately. So that is how the motion of the ball is built over here. And the simplest third point is to restrict the ball bouncing only from the handle below and from those tiles on the top. That is done by saying that if the x coordinate of the handle and the x plus width of the handle are, so x coordinate of the ball is between these two x and x plus width of the handle, so that the ball is meeting the handle and then only you reflect, otherwise you do not reflect. So this bold code over here, the highlighted code, it will indicate that if the ball is hitting the handle, same will apply if the ball is hitting the bricks on the top, then you bounce, otherwise you don't bounce. So these are like three probably 20 lines, 25 lines of code with which you can build the demo that I showed you. Let's move to an HTML5 piano. Again, this piano is built purely using HTML5. I can say sare gama. And the interesting thing over here is that the sound that you heard just now is not stored on any server, it's not stored in any MP3 file, it is not being streamed from anywhere, but it is generated on the fly using HTML5's audio synthesis API when I press the key. I'll show you on the next slide how this is done. So a little bit of audio related code which I myself don't understand, but there is an audio header. Every audio file has an header, so I just copied it from one of our previous demos. So this is how an audio file's header looks like. There are a couple of 0000s on the second line and the last line. These are important ones. These are the places where we will put the total size of the file and the offset and what total number of samples over there. So this is how an audio header is done. I will come to this slide later on. But this is where I am going to play a note given a frequency and given a duration. So when I specify the frequency and duration in the function, initial some amount of audio processing code, and after the for loop you can see that there is an array of audio samples created. I create a wave out of it. On the previous slide I am showing how to create a wave. So I am saying again a little bit of HTML5 code. WebKit block builder and data view are like new low level APIs that help you to get access to arrays with data types or blobs with data types in JavaScript. So till now JavaScript did not have data types, but henceforth with HTML5 JavaScript is now supporting a couple of data types, and these are some of them. So you have a data view which is a low level handle to an array. I take that and you can see that I am setting the size of the sample and a couple of more stuff in those 0, 0, 0, 0s which were there in the header. Once that is done, I am creating it a blob of the format audio wave and I am returning it. Once that is done, after the for loop, I get a blob which is now a proper audio file, and I get an object URL. We have seen this function previously also. Get an object URL which creates a proper URL that an audio player understands, and the audio player is passed this object URL. This audio player is also an HTML5 native audio player, because with HTML5 you can have now there is no need of having plugins for audio and video. You can have audio and video support directly in HTML5. So this is how you pass the URL to the player, and then you can call play so that the given URL plays. And of course, once it ends, we want to revoke the object URL. So for example, whichever frequency we will add over here, it will play the note of that. Okay, let's see some low level frequencies. I'm just adding random numbers. Okay, so whichever frequency you add over here is generating the URLs on the fly. On the right side, you can see the exact blob of the URL. It says blob is http:/localhost and whatever is list over there, and it gets revoked after the player ends. So here, look at the keys. Here is a small happy birthday song in case somebody's birthday is today. So look at the keys. It's generated while it's being played. It's not stored anywhere. Okay, let's move ahead. I think 5 more minutes. We'll move ahead to 9th and 10th demo. So this is an HTML5 based later on. This is an HTML5 based terminal, and there are a couple of interesting things that can be shown over here. For example, there are files over here, and I can add, hope that it is, say I can drag a couple of files and I can, wait. Okay, there is, you can see the files added over there. So using drag and drop, I'm able to add files from the desktop. I'm sure you all have seen this feature in Gmail where you can drag attachments and add it to your mailbox. And there is also an interesting feature over here where you can use WebGL and see the 3-dimensional view of your file system. So if I say 3D, it's going to show a 3-dimensional view of the file system, and I can probably change the way it looks like. So this is exactly the list of files that it is showing over here. If I, okay, this is the ticket. Okay, so this is how the drag and drop, and I have already explained how drag and drop works, and the 3-dimensional view is made possible by using WebGL, which is like 3-dimensional counterpart for Canvas. There is one new thing going on over here which I want to talk, and that is about the file system. So HTML5 gives you a way to access the local file system, not the actual disk file system, but a local sandbox, and it gives a sandbox per user, so you cannot interfere with some other users. So it says, so on the first line, I am getting an access to this sandbox. It says windows.request file system, and whether I want a temporary access or a permanent access and all that. And once I get an access, I am accessing the file system fs.root. The reason why I am using root over here is that every file system has a different root, and so if I say fs.root, it maps to the root that of the file system that is given to me by the browser. This all happens internally. So I say fs.root.getFile, and then I can read a file, write a file using a couple of APIs like file entry.createWriter, createReader, or remove file and all that. So these are the functions that were used in the previous demos to read the file from the desktop, to add it. When I say ls, you saw a couple of files over there which were being read from the sandbox. So that's drag drop was taking the file from the desktop and reading it to putting it in the sandbox. So 2-3 minutes, so I can just move to the last demo. Again, this is a complex WebGL based demo, so I don't have time to explain the code behind it, but this is a 3-dimensional view of Google bookcase, and it's WebGL based, so you can have a lot of interaction with it. As you can see, it's actually pretty cool, isn't it? Okay, so this looks very interesting. It's not at all complex. It's basically capturing the mouse and making rotations possible. I've already shown you how to do rotations in a couple of other demos. I think that completes the 10 demos that I promised to start with. There are a couple of more which I have listed over here. Let's see one of them. For example, there is this blow up this video. This is a video which is running and there is a canvas being overlaid on that, and that canvas takes various actions. So you can see this. Okay, you can blow up this video and then these fragments will again come back. Okay, I have not developed this, it's on internet. So all this collabs go to that person. Yet another thing that you might want to see is this. Again, this person is built all using CSS. There is no JavaScript going on over here. And I'll just show you the magic behind it. It's only a couple of divs that are being transformed and animated using certain functionality, like, and some images have been put around it. So that's it, nothing interesting beyond that. And it's again all CSS based. And then we developed a nice Chrome logo a couple of months ago. We means people at Googlers developed a nice logo a few days ago. And let's see, this is again based only using Canvas. I'll just reload it so that it works. Just I'm just clicking so that it's bouncing. That Doordarshan used to come a few years ago on TV, something like that. Okay, so there are a couple of more demos over here, links you can go through, and I did not run through really a lot of stuff of HTML5 Pro. Just hold on, I think some video is running somewhere. Yeah. So I did not run through details because it's all available in the books. I just wanted to show a couple of demos that I tried to build so that this presentation looks interesting. And these are a couple of links that you might want to go for. So there are articles, there are a lot of presentations online, there are demos. You can file bugs for Chrome and we'll get back to you. Finally, if you want to have access to this presentation. So if you want to have access to this presentation, you can go to bit.ly/html5magic. This presentation is hosted online. You can refer to it. You can study using it. You can download it. Feel free to do whatever you want. bit.ly/html5 numeric 5 followed by MAGIC magic. Okay, that's all I think. I don't have time for questions, but I'll be available outside for probably half an hour more. So thanks a lot and enjoy your evening.